Having trouble getting a locate signal to the end of the line? Your problem is most likely caused by a resistive fault to ground. Today we're going to show you how Norscan's cable monitoring can alert you when faults occur, and how to properly isolate where those faults are located within your network. Norscan's cable monitoring watches your cable for 3 possible issues. The first is a lack of end-to-end connectivity. This triggers a line alarm. Second, moisture within the splice enclosure. This triggers a sensor alarm. And finally, resistive faults to ground. These trigger a cable alarm, and this is the scenario we're going to go over today. So your 4200 CMS is displaying a cable alarm, letting you know there's a fault on the line. What's next? To find faults, you will need a 1303 system test set. With this tool, we'll be testing the voltage on the line. The key takeaway here is that voltage readings of -48 VDC indicate no fault present, while anything less than -48 VDC indicates a fault is present. The first step is to ensure that your Norscan equipment is properly working and that the alarm is valid. Begin by disconnecting the outside plant cable armor from the protection devices installed within your central office. Once disconnected, connect your system test set to the protection devices and verify that it reads -48 VDC. This indicates that your equipment is working properly and that the fault lies somewhere in your outside plant. Reconnect the outside plant to the protection devices and record the system test set reading. In this example, let's say it's -24 VDC, which indicates there's a ground fault and voltage drain on the 4200 CMS. Once you have verified that your equipment is operational, it's time to isolate the fault. How? Disconnect and double check. To isolate a fault, we work our way out from the central office, disconnecting segment by segment. Each time we disconnect, we also double check the voltage reading on the system test set. If it reads -48 VDC when a segment is disconnected, we know the fault is still further out. If it reads your original VDC reading, in our example it's -24, then we know the fault lies within the segment from the last -48 VDC reading to the series bond you just disconnected. We can use the same methodology on a branch network. Once at the branch point, disconnect all lines and one by one, reconnect and double check. If after reconnecting a segment reads -48 VDC, we know that the fault does not lie within that branch. If it reads your original VDC reading, once again in our example it's -24, the fault lies somewhere within that branch and we can continue to disconnect and double check to isolate the faulted segment.